Hello everyone. Today's lecture is on thresholds, psychophysics, and sensory test design considerations. Once again, here is our favorite definition of sensory evaluation that I recommend burning into the back of your eyelids because it is very likely that you will see this one again. So we have two objectives today. We're going to talk about how to evaluate psychophysical laws and how they influence the perception of stimuli. As food scientists, we are used to using the laws of physics and whatnot to think about what happens in food from a physical and chemical perspective. When we start dealing with sensory, we have a new layer of laws that we have to consider, and that's the consideration of the psychology of how decisions and things are made. The second thing that we're going to do is talk about key statistical considerations that influence how sensory tests are designed and how data is collected. So first of all, we're going to backtrack a little bit. We're going to talk about the psychology of perception, and we're going to talk about thresholds. There are four types of thresholds that you need to understand. And the first one is an absolute threshold, and it's the lowest stimulus capable of producing a sensation. So if you think of having a glass of water and you add in a grain of salt, 1 grain of salt at a time, how many grains is it that you add to that water before you can say, this is no longer water? There's something else that's happening. That is the absolute threshold. So once we've reached the absolute threshold, then continue to add a single grain of salt into that water. When you've added the grain of salt and you can say, I know there was something more than water. Now I can name that stimuli that's being added to the water. Now I can call it salt. So the absolute threshold is when you know something is different in the glass of water. The recognition threshold is the threshold where you can actually name what is different. The next threshold is called the just noticeable difference threshold, and you'll see this abbreviated a lot of times as JND. So if you see some of my notes or things and I say J and D, what I'm referring to is just noticeable difference. So let's go back to that glass of salt water. You've added enough grains of salt to say, it was water, now it's water plus something. You continue to add in grains of salt, and now you can say it's water with salt in it. You can name the stimuli that's used to change that perception of that glass of water. The just noticeable difference threshold is the number of salt grains that you have to add to that water to say there's been a change in concentration. So the just noticeable difference threshold is how much of the stimulus has to be added in order to make a noticeable, perceptible change. And I want to make this mention this here. You guys are smart. You know how to analyze 4 components in food, and you can measure it with some sort of instrument. But you have to remember, an instrument isn't going to tell you how a consumer is perceiving those changes. You have to have the consumer response in. And so when we're looking at this just noticeable difference threshold, even though you can mathematically, analytically quantify a difference in that attribute or that compound, the consumer or the subject needs to be able to detect that increase in that compound or decrease in that compound has occurred. Now, with the just noticeable difference threshold, you're thinking, okay, big deal, this makes a lot of sense. But let's think a little bit about Campbell's soup. Campbell's soup several years ago got public criticism for the amount of sodium that it had in its canned condensed soups. And as food scientists, we know that salt is put in there as one of the hurdles in the hurdle effect for food safety, because if you're putting all these materials together, number one, you have to apply a heat treatment. Number two, it's always best to have some sort of preservative in there. You don't want to do just one treatment when you put a product on a shelf. You want to have more. So if you think about it, you've retorted that can of soup, you have added salt in it, so you've got two hurdles in terms of food safety protection. But if the consumer is wanting to take salt out of that canned soup, what's going to happen with the consumer? What's going to happen with the consumer is that if you take out 20% of that salt right away, we know we're going to have a flavor issue, and we know we could potentially have a food safety issue. So you can't just take 20% of that salt out of that product. What you have to do is you have to slowly step that salt reduction down. And you have to do it where this just noticeable difference cannot be detected. So when you're dropping that sodium level down, you want to be able to make sure that you understand that the consumer cannot detect that. So this is where these just noticeable difference thresholds are important. You could think of it, so here's going from a higher concentration down of salt to a lower concentration. Here's another way you can think about it. I need to add in this ingredient that is an antimicrobial, and if you add it in at too high of a level, it can provide an off flavor. So what is the highest amount of that antimicrobial that we can put in that food product to protect it to be safe without being detected? So you have to slowly look at how much you can inch that up where you're not getting a perceivable detection by the consumer. Because at the end of the day, the consumer decides what they're going to buy, and if they're detecting differences and if they don't like their differences, they're not buying your product anymore. So in cases like this is where understanding where that threshold is important. Now, this terminal threshold is how many grains of salt can you keep adding before you can't perceive a difference or a change in intensity. So let's pour, a quarter a cup of salt or an eighth of a cup of salt in a 16-ounce glass of water. We would all agree that's salty, and we'd probably say, you know what, Dr. Lambert, that's when we're actually using salt water to gargle with because we have a sore throat. So at some point, you get so much of a stimuli in there that that threshold is not going to increase. It's going to level out. And these are very important thresholds to think about because they have some very real-world applications into some of the things that you may do in the future. In the past, we have conducted a lab on collecting and analyzing threshold data for bitterness. And this was a very, very tedious preparation for my grad students and TAs to prepare this. Sorry about the beep and another beep. It was very tedious, and understanding thresholds is one of the expectations in IFT for a sensory class. And what we're going to do is we're going to skip the labor-intensive prep, and we're actually going to, in our lab next week, analyze threshold data on the Sunstruck flavor in beers. So even though we won't collect the data, we'll walk through how the data is collected. We'll get a data set that we will then analyze on Sunstruck flavor in beer. And Sunstruck flavor in beer is the off flavor that is produced in beer bottles when they have clear glass instead of dark glass. And we'll go through that, but I thought it'd be an interesting set of data, that you might enjoy analyzing. Okay, so one of the things to think about is we've talked about the physiological perspective and we've talked about the psychological perspective on collecting sensory data. So when we think about the physiological perspective, we're talking about the sensory modalities, and we talked about the 5 sensory modalities, the seeing, the hearing, the tasting, the touch, and the sound, and the touch being the mechanical movements. And we understand that, each of the senses has limitations. If you're colorblind, you can't see the colors. If you have certain bitterness genes, you're super sensitive to changes in bitterness, where someone who doesn't have those genes cannot detect the bitterness like a super taster. Those who are deaf cannot hear the crunch of a food. The other thing that we talked about was the psychological perspective and some of the psychological errors, the halo effect, the mutual suggestion. We talked about how those influence our measurements. And just like when we think of a pH, actually, let's do this. Let's talk about water activity. We know to measure water activity, we can get a bunch of water activity values, but the best way to compare them is when they're taken at the same temperature all the time, because if you change the temperature, we know that water activity values change. Well, when we're thinking about sensory, just like in water activity, when you have to control the temperature and account for the temperature that you're getting that measurement at, when you're doing sensory testing, you have to consider the physiological and psychological perspective. Now, the psychological perspective is rooted in a branch of psychology called psychophysics. And psychophysics is a branch of psychology that examines the relationship between a physical stimuli and a mental phenomena. So, if I am drinking my Pepsi, my Max Taste Zero Sugar Pepsi, that is the stimuli. And so when I consume that Pepsi Zero, what is happening when I'm thinking, when I consume that Pepsi? How the psychology of what I'm thinking changes before and after we apply a stimuli. So, if we're going to ask people to evaluate food, they'll have a state before they consume it and a state after they consume it. And that stimuli is the food, and how you understand from a psychological perspective what happens is called psychophysics.